This one is 3 times the square root of x plus 5x. And if you want, you can imagine, say, the square root as x to the 1/2. It usually makes doing the derivative a little bit easier. So doing my first derivative, I was thinking of bringing down this power, so the 1/2 would multiply by the 3. Now to get 3/2 x to the negative 1/2 plus the derivative of 5x would be 5. Okay, not too bad. Let's do another derivative. So this is the second derivative. And I'd bring down this power. So now I have a negative 1/2 multiplied by a positive 3/2. So negative 3/4 x. This power gets reduced again. So negative 3/2. And the derivative of a constant is now gone. So that's just 0. All right, let's find one more of these things. Third derivative. So now think of taking this power, bring it down, multiplying it out front. Negative times a negative would give us a positive. So positive 9/8 x to the negative 5/2. And we really could continue on from there, just continuing, bringing down the power. And this one's kind of a neat one. You'll notice that the signs actually alternate. We'll get, say, a negative in our derivative here. This will be positive. The next one, this negative will come down. We'll be getting another negative in there. It just keeps flipping back and forth. All right, so that's pretty neat. Let's go ahead and try our higher derivatives on one more example. And let's go ahead and throw in a product rule, okay? In this one, I want to find a couple of derivatives for 2x squared plus 1 multiplied by 4x squared plus x. So in order to do my first derivative, I recognize that I really have two functions in here. Maybe call the first one something. I'm going to call it u. And call the second function something. Let's call that v. That way I can do my product rule. u v prime plus v u prime. All right, let's see what that looks like. So my first function, just as it is, 2x squared plus 1 multiplied by the derivative of this one. That'd be an 8x plus 1 plus. Now we do our second function just as it is. Multiplied by the derivative of the first one. 4x. And then that one's done. Okay? So now we can take two derivatives of this by doing the product rule twice. So I'm going to call these u and v again, even though I probably shouldn't since I already used a u and v once before. But I don't think I'll get into too much trouble. So let's call this a u and a v. And apply our product rule just to these two pieces here. So my first function, 2x squared plus 1. Derivative of the second, that would simply be just an 8 plus. Now I have my second function times the derivative of the first, 4x. Okay, so that takes care of the derivative of those two pieces. Now let's also find the derivative of these next two pieces, again by recognizing the two functions that are really being multiplied together. So let's see. Our first function just as it is, 4x squared plus x. Derivative of the second, 4, plus the second function, 4x, multiplied by the derivative of this one. I get 8x plus 1. Okay, so we've actually found two derivatives, and all you would really have to do from here is start cleaning things up a bit, maybe by distributing and combining as many terms as possible. Let's go ahead and do that just so we can finish the problem. So I get a 16x squared plus an 8 plus 32x squared plus 4x plus 16x squared plus 4x. See, now I need to distribute this one in here, plus 32x squared plus 4x. A lot of different things in here, a lot of different things. Here are all of my x squareds. So we'll be sure to combine those ones. Let's see, I also have some x's. We'll combine those ones. Looks like we have a single 8, so that will just I guess, be all by itself when we're all done. So I get a 96 x squared from combining all of my x squared terms, plus a 12x that comes from both of these x's, and then there's my 8 all by itself. So there's two derivatives of our original functions. So if you can just remember that with these higher derivatives, we're taking derivatives of derivatives, and apply your rules carefully, you'll be just fine. If you'd like to see some more videos, please visit mysecretmathtutor.com.